Thank you to watching Shoaib Views. This is the last part of steam generation topic. In part 3 we discuss about efficiency of boiler. If you like my video, please subscribe, follow and like my channel. Improving efficiencies of steam generation system. This part covered the energy conservation, use of economizer and use of waste heat, energy losses, heat carried out with stack flue gases, heat carried out with stack in the form of water vapor, unburned fuel, incomplete combustion, heat losses from boiler, heat waste through blowdown, heat losses. Having discussed combustion in the boiler furnace, and particularly the importance of correct air ratios as they relate to complete and efficient combustion, it remains to review other potential sources of heat loss and inefficiency. Heat losses in the flue gases. This is probably the biggest single source of heat loss. The losses are attributable to the temperature of the gases leaving the furnace. Clearly, the hotter the gases in the stack, the less efficient the boiler. The gases may be too hot for one of two reasons. The burner is producing more heat than is required for a specific load on the boiler. This means that the burner's and damper mechanisms require maintenance and recalibration. The heat transfer surfaces within the boiler are not functioning correctly, and the heat is not being transferred to the water. This means that the heat transfer surfaces are contaminated and require cleaning. Some care is needed here. Too much cooling of the flue gases may result in temperatures falling below the dew point, and the potential for corrosion is increased by the formation of 1. Nitric acid from the nitrogen in the air used for combustion. 2. Sulfuric acid if the fuel has a sulfur content. 3. Water. Radiation losses. Because the boiler is hotter than its environment, some heat will be transferred to the surroundings. Damaged or poorly installed insulation will greatly increase the potential heat losses. A reasonably well-insulated shell or water tube boiler of 5 megawatts or more will lose between 0.3 and 0.5% of its energy to the surroundings. This may not appear to be a large amount, but it must be remembered that this is 0.3 to 0.5% of the boiler's full load rating, and this loss will remain constant, even if the boiler is not exporting steam to the plant and is simply on standby. Boiler net efficiency percent chart. In this chart you can see the boiler types and their efficiencies. Factors affecting boiler efficiency. Now discuss the factors which are affecting on boiler efficiency. 1. Excess air rate. 2. Burners. 3. Firing rate. 4. Flue gas temperature. 5. Feed water temperature. 6. Condensate recovery. 7. Combustion air temperature. 8. Fouling of heat transfer surface. 9. Blowdown. Combustion air control. Excess or less air. Accurate control of the amount of air is essential to boiler efficiency. Too much air will cool the furnace and carry away useful heat. Too little air and combustion will be incomplete. Unburned fuel will be carried over and smoke may be produced. In practice, however, there are a number of difficulties in achieving perfect stoichiometric combustion. The conditions around the burner will not be perfect, and it is impossible to ensure the complete matching of carbon, hydrogen, and oxygen molecules. Some of the oxygen molecules will combine with nitrogen molecules to form nitrogen oxides NOx. To ensure complete combustion, an amount of excess air needs to be provided. This has an effect on boiler efficiency. The control of the air-fuel mixture ratio on many existing smaller boiler plants is open loop. That is, the burner will have a series of cams and levers that have been calibrated to provide specific amounts of air for a particular rate of firing. Clearly, being mechanical items, these will wear and sometimes require calibration. They must, therefore, be regularly serviced and calibrated. On larger plants, closed-loop systems may be fitted which use oxygen sensors in the flue to control combustion air dampers. Air leaks in the boiler combustion chamber will have an adverse effect on the accurate control of combustion. Burner. The ability to burn fuel all efficiently requires high fuel surface area to volume ratio. Experience has shown that all particles in the range 20 and 40 micrometers are the most successful. Particles which are bigger than 40 micrometers tend to be carried through the flame without completing the combustion process. Smaller than 20 micrometers may travel so fast that they are carried through the flame without burning at all. An important function of burners is turndown. This is usually expressed as a ratio and is based on the maximum firing rate divided by the minimum controllable firing rate. The turndown rate is not simply a matter of forcing differing amounts of fuel into a boiler. It is increasingly important from an economic and legislative perspective that the burner provides efficient and proper combustion and satisfies increasingly stringent emission regulations over its entire operating range. To be continued. You are watching Shoaib Views. In this video I discussed some point to effect on the boiler efficiency. Next episode I will discuss more points on this topic. Thank you for watching my channel. If you like my effort, please subscribe my channel where you can see more videos on different topics like technical, automobile, Islamic and much more. Please like, follow and share my channel.